The homework for tonight is page 4 in the MSG. Here is a detailed solution set for all of the problems on page 4 in preparation for our test on Friday. So the first problem is to find the greatest common factor of 30 and 48. So the way that we did this in class for the most part was we took 30 and 48 and we put them on a sled. Then we looked for any common factor that we saw between 30 and 48. Now this is where your answers might look a little bit different, but I see that there's a 2 in both of these numbers. So I'm going to divide by 2. That leaves me with 15 here. 30 divided by 2 is 15. 48 divided by 2 is 24. Now I look, are there any common factors still in that set? And there are. There's a common factor of 3. So I'm going to do this sled again. And 3 goes into 15 5 times, and 3 goes into 24 8 times. Since 5 and 8 share only a common factor of 1, we know we've done that part of the problem. So the last thing we have to do is figure out what the greatest common factor, or the GCF, is. Well, as we've said in class, the GCF is on the left. So we take all the factors that we pulled out that they shared in common, and we multiply them. So our GCF will equal 2 times 3, which equals 6. In problem number 2, we are looking to find the least common multiple of 10 and 6. And so we start off by doing the exact same thing. We put 10 and 6 on a sled, and we're looking for the common factors between them. So 10 and 6 share a common factor of 2. That's the number I'm going to pull out. I'm then going to divide 2 into each of these numbers. So 10 divided by 2 is 5, and 6 divided by 2 is 3. Since 5 and 3 share no other common factors other than 1, I know I've done my math. Now, least common multiple, LCM, is all of them. And what we mean by that is this. We take all the outside factors and we multiply those together. So the LCM equals 2 times 5 times 3, which is 30. In problem number 3, it asks you which choice lists all the factors of 48. There's lots and lots of factors of 48, and we're looking for the list that's all-inclusive. 0 cannot be a factor of 48 because nothing times 0 equals 48, so I can cross that choice off. We know we definitely need a 1 and a 48, and we have that combination. We go to the next factor. Well, is 2 a factor here? It sure is, because this is an even number, and 2 goes into every even number. Turns out it's 2 times 24. So far, all of these factors are found in each of these groups. We're looking to sort of narrow it down. Then we check to see if 3 is a factor. Well, if you add 4 and 8, you get the number 12, and 12 is divisible by 3, so that means 48 is divisible by 3. So A cannot be our answer because it's missing the factor of 3. 3 goes into 48 16 times, so that's here, and it's not here. So the only answer choice that works would be B. The question here on number 4 is asking, is it possible to have a greatest common multiple? Yes or no? And the answer is no. Multiples go on forever. In class, we talked about how I could stand here and I could do all the multiples of a number till I die. Somebody else would have to pick up and keep going, and it would keep going and going and going forever. It's an infinite, okay? Multiples go on forever. There is no greatest common multiple. Question number 5 asks us, is it possible to have a least common factor? Yes, it's possible, but every single pair of numbers have one factor in common, and it's the lowest for all of them. So yes, 1 is the least common factor between any two numbers, between any group of numbers. So it really doesn't help us give us any information about those numbers because 1 would be the least common factor of any set. All right, we're not going to do the decimal portion here because we did not learn that. We're going to come back to that at the second half of the unit. But for this problem, let's take a look. So this is a long division problem. We're going to find the quotient. 2 goes into 5 2 times. 2 times 2, so that's the division. Then we do 2 times 2, which is 4. Then we subtract. Then we bring down. 2 goes into 13 6 times. 2 times 6 is 12. Then we subtract. Then we bring down. And 2 goes into 17 8 times. 8 times 2 is 16. Then we subtract. We have 1 left over. Well, we have 1 piece left over when we needed 2 to make another group. So the answer is 268 and a half. And just in case somebody gets ambitious, that's equivalent to this. But we are going to talk about that after we take our first test. In the next problem here, we're going to look at how many times 15 goes into 6. Well, it doesn't go into 6, but it does go into 61. And it goes into 61 4 times. And 4 times 15 is 60. Then I subtract and I bring down. 15 does not go into 13, but every time I bring a number down, I have to make sure I put 1 up. So there's a 0, and 0 times 15 is 0. When I subtract, I get 13. And then I bring down the 8. And 15 goes into 138. That's going to be a little trickier. We have to think about it. Well, it went into 60 4 times, and there are 2 60s in here. So we're going to talk about at least 8 times. So I'm going to check that. 15 times 8 is 120. Can I get another 15 in there? Sure. So if I add another 15, I end up with 135. That's as close as I can get to 138 without going over. And if I already had 8 factors and I add another one, that means it's 9 factors. And that will be 135. When I subtract, I get 3. That's 3/15. Now this answer isn't finished because we still have to simplify that. 3 and 15 share a factor, share a factor of 3. Divide by 3, divide by 3. You're going to get 1 and 5. So it's going to be 409 and 1/5. And just as a refresher, I did all this math by using my voice, and I apologize that it was off the screen. So if you need to go back and listen to it, you can still see all the steps that are here. Try to do better next time. Talia has 28 pencils and 42 erasers, and she's splitting them into bags for new students. Each bag will have an equal number of pencils and erasers. We want to know what the maximum, and that's the key word here, maximum, number of bags she can make, and how many pencils and erasers will be in each bag. So we're going to use maximum means we're looking for greatest, which is GCF. So we take 28 and 42, and we put them on a sled. And what number goes into both 28 and 42? Well, I know 7 does. That leaves me with a 4 and a 6. And 4 and 6 still share a common factor because they're both even. So I'm going to pull out a 2. 2 goes into 4 2 times and into 6 3 times. Now I'm done because 2 and 3 don't share any factors other than 1. So since I was looking for GCF and it's on the left, we can make 14 bags. 7 times 2. Now, if I'm making 14 bags, how many groups of 14 are in 28? There's 2. So I will have 2 pencils per bag. And how many 14s are in 42? There's 3. So I will have 3 erasers in each bag. Let me say that one more time. If I'm making 14 bags, I have 28 pencils. That means 2 pencils will go in each bag. If I have 14 bags and I have 42 erasers, that means that 3 erasers will go into each bag. All right, the next problem says that hot dogs come in packs of 8 and hot dog buns come in packs of 10. I want to know the least number of packs of each that can be bought to make hot dogs, like a hot dog that you would eat, 1 hot dog and 1 bun, with no hot dogs or buns left over. The key word here is least. It's the smallest number, so we are looking for LCM, the least common multiple between these. So we take 8 and 10 and put them on a sled. I know that 2 goes into both of them. 2 goes into 8 4 times, and 2 goes into 10 5 times. Now, LCM is all of them, and I know I'm done because 4 and 5 only share a common factor of 1. So if we take all the factors, we multiply. 2 times 4 is 8, and 8 times 5 is 40. I can make 40 hot dogs. Now, if the hot dogs come in packs of 8, how many bags will I need? I will need 40 divided by 8. So I will need 5 packages of hot dogs. And if the buns come in packs of 10 and I need a total of 40, I will need 4 packs of 10 to make 40. And that's the answer there. A shipment of 478 textbooks came to a school. The books are being given out in class sets of 25. How many classrooms will receive a full set of textbooks? So here's the deal. There may be some leftovers, but we're looking for how many can get a full class set. So we're going to take 478 and we're going to divide by 25. 25 does not go into 4, but it does go into 47 one time. I'm going to raise this up so you can see a little bit better. And then we multiply, and then we subtract, and then we bring down. And I know that 25 goes into 104 times, and there's 2 of those, that makes 8, plus 1 extra over here. So 9 times 25 happens to make 225. That leaves me a 3. This 3 is the leftover books. I can't use those books to make a complete set of anything. So I will be able to make 19 full sets. There will be 3 books left over that we can maybe use later, but they asked only for how many full class sets I could make. So the answer is 19. We would round down, and we wouldn't even look at those remainders. All right, in the last problem, there are 1,460 people waiting to ride a roller coaster. Each cart takes 30 people at a time. How many carts will it take for everyone in line to have a turn? Well, in this case, we still do our division because we want to find out how many groups of 30 we can get out of here. 30 doesn't go into 1, doesn't go into 14, but it does go into 146. So I use a little front-end estimation here. I look at the 3 and I look at the 14. About how many 3s go into 14? That's about 4. So let's try 4. That gets me 120. If I add another 30, I'm going to be all the way up to 150, and that's just too much. So I know that 4 is the correct estimation, and then I'm going to subtract. Bring down. And how many 30s go into 260? Well, again, look at those front numbers. How many 3s go into 26? That would be 8. So let's try that. 30 times 8 is 240. And if I add another 30, that's going to get 270. So 8 is the maximum I can put here, and that will be 240. Now I have 20 down here. Now in this case, the 20 represents people who want to ride. I still have to make sure that they ride the ride. So 48 full carts are going to go down, but I need to add an additional cart to make sure that those 20 people also get to ride. So there will be 49 carts to make sure that everybody gets to ride. Hope this was helpful and hope you guys use this guide to prepare for your test on Friday.